Yes, is this Nicholas Veronico?
Speaking.
This is Nicholas Veronico.
Yes, who's this?
How you doing, Mr. Veronico? My name is Robert Bassano. I'm a graduate student. Um, I'm studying artificial intelligence at Stanford. I was wondering if you personally could be able to provide me with a little bit more detail on the Sophia platform, or if you could recommend someone I could speak to. I'm working on an application that would allow for a machine learning program to pick up and identify specific objects using high performance optical telescopes.
My instant thought is that there's a problem there because we see in the infrared.
You see in the infrared.
Yeah, so Stratospheric Observatory for Infrared Astronomy.
Okay.
So it's not. We don't see things like an optical telescope. We have to find like stars near our infrared source, and we focus the telescope on a black spot in space.
Okay.
And then we get the infrared radiation through our instruments.
So Sophia views everything in the sky on an infrared scale, on wavelength, right?
That's where we do our research. We do our optical guiding through what you and I see.
Okay. So let's just say, whatever I'm seeing up in the sky, if I can see it with ground-based telescope, you would be able to see that same object in infrared.
Yes.
Okay. So now how
see things you can't see it with an optical telescope.
Okay. Now how does that compare to HST? Is Sophia linked? Is Sophia linked with HST?
No, they see out to about 5 microns in the infrared.
Okay.
And we go out to 250 to 300 microns right now.
Whoa. Wait. Are you serious? So wait, you're saying Sophia, which flies at around 45,000 feet, can see nearly 150 times further than Hubble in the infrared?
Yes.
Wow, Nick. Wow.
How
is that? Yeah. How is that possible?
Because we're two different. We're apples and oranges. That's how.
Apples and oranges. So I like oranges. It's good in vitamin C. So which one? How big would be your orange, and how big would be the apple?
So actually, both of our telescope mirrors are about the same size.
Yeah, I noticed that.
6 inches.
Yeah.
100.
And I absolutely didn't. Go ahead. Sorry.
It's the instruments they use are different than what we use, and that's really the only difference.
Yeah, and that's what I was trying to determine, because I conducted a comparison of the technical specs of HST and the technical specs of Sophia. So, and I know that the Sophia program, well, not the Sophia program per se, but the Stratosphere Observatory platform is older than HST. You guys have just been doing it on different aerial platforms, and it just grew to a 747. That's what I've been doing the history on. But I noticed that the technical specs are almost similar. But I'm trying to wrap my head around, how is it possible you have HST, we're supposed to be 330 miles plus, beyond the exosphere, and you've got Sophia, which is in the stratosphere. You guys are looking far beyond. You're looking through another couple of layers and looking way past HST, and you're able to capture things on a much more, would it be fair to say, a high definition type of quality in infrared?
I don't know about that, but so NASA has HST, they have Sophia in infrared.
Okay.
They have Chandra and X-ray. They have all different observatories to cover all of the electromagnetic spectrum.
Okay.
And if we all look at the same thing, the same object, you're going to learn something different depending on, what wavelength you're looking at it.
Okay.
So that's why we have all these different telescopes. We can do things that others can't do, and they can see things that we can't see. So it's a good marriage.
Now, has there been occasions where Sophia and HST are taking the same exact photo of the same exact object on the same day?
No.
No.
No. What happens is we put out a call for proposals. As a matter of fact, there's one open right now.
Okay.
And we take all those proposals, and they decide what is the best use of Sophia.
Okay.
And then they award time to those proposals, and we go out, and let's say you got 8 hours of observing time on, some star-forming region.
Okay.
You might get 3 hours on one flight, an hour and a half on another, 2 hours on one, and
How many platforms are there for Sophia? Is there just one aircraft?
One aircraft, but we have 7, 8 different instruments that we can use.
Okay.
But we only fly one instrument at a time. It takes about 2 days to change it.
Now,
There's
is Sophia still based in New Zealand, or is it in the U.S.?
It's out of Palmdale is where the airplane resides, but the scientists are all in Mountain View.
Okay.
And we're having a science seminar, a conference in down by Santa Cruz at the Asilomar Conference Center in October.
Okay.
And that's something you might want to go to.
Asilomar.
And and let me see if I can let me get my computer started, and I'll
Yeah, because and something else that's interesting, because here's the thing. I had been looking at some of the images from Sophia and HST, and I know this may sound weird, Nick, but I found a comparative photo from a ground observatory, Sophia and HST, of the M82 supernova. The photo was taken around January 22nd of 2014. Now, hold your oranges and apples for this one. They were taken on the same day.
Yes. As a matter of fact, I think I was on Sophia for that picture.
You're kidding. You were on Sophia when that picture was taken.
Yep.
So you were on board when the infrared was taken of the M82 supernova on January 22nd, 2014.
Yeah.
Oh man, did I get lucky with you? Did I get lucky with you? Man, thank you so much for verifying that. Is there any way you could actually email me because I get the information online on you guys' site, but a lot of the information is just scattered all over the place because I'm not even sure if the photos for Sophia online on NASA are up to date, because I'm getting very limited from HST team. I spoke to people at HST, and you want to hear something interesting? Have you ever seen HST in real time in operation?
No.
You've never seen it. How long have you been with the Sophia team?
8 years.
8 years? Well, here's the thing. Director Bolden was the mission commander for HST when it launched. Well,
right.
And they had the servicing missions. So I had a talk with one of the deputy program managers, and he had been working on the HST team for 25 years, and I was. Are you familiar with the FAI database? Federation Aeronautique Internationale?
Yeah.
Okay. Well, you know that vast majority of all of the STS missions are on that database, including Apollo and all the Russian launches in other countries, including Phyllis Baumgartner's records on there. So I went searching because I needed to know at what altitude did the STS-31 got to basically deploy HST. And I saw a recent video on JPL, it's on their website, where they show the 2002 servicing mission. And it dawned on me that STS in 2002 was on top of HST. Now, I thought that was actually a weird photo because it shows the Earth on the bottom, of course, and then it shows the STS shuttle on top of HST, servicing it, getting ready to deploy it. And then when I asked a question of HST team members, I said, wait a minute, when I put in, the flight date for HST in 1990, it's not there. And the response, was what I expected. NASA doesn't manage the FAI database. But when you put in the servicing missions, most of the servicing missions are there, but 2 of the servicing missions are not listed. Well, here's the kicker. HST launched April 24th, 1990. If you put in that flight number, the year, all of the crew member's name for that flight, it's not in the database. So I asked HST, is there a reason why someone didn't submit the application or the documentation to the FAI for this? He says, I don't know, we don't manage that database. I said, that's understandable. And I said, but how is it that some of the servicing missions that are there, but the main mission to put HST at 330 miles is not there? That was supposed to be the greatest mass lifted to the greatest altitude. And I put in all the variables. I contacted AFI. They said that there was no problems with their database. They even looked back in their records. It took them about, a month and a half. And they said, well, we don't even have an application or any documentation that was filed for that mission. He goes, you might want to call back to NASA and ask them. So, of course, I called NASA to ask them. And, you figure in 25 years, somebody who's responsible for doing this, which they don't know who's responsible for doing it, they all said, that's interesting, just like you just did. That's interesting. So I asked the deputy project manager, is it possible? Have you ever seen HST? He says, no, I've only seen it on the servicing missions. I said, okay, you've seen the servicing missions. I said, but nobody's ever set eyes on it? He goes, no, we don't have optical tracking. I said, okay. I said, are you familiar with Sofia? He says, yes, somewhat. So when I told him what the capabilities of Sofia was versus Hubble, he says, no, you got it all wrong. Sofia can't do infrared and wavelength like Hubble. I said, that's not true. I'm on Sofia's website right now. And it says it in the OIG, Office Inspector General report, what Sofia is capable of doing in wavelengths. And I tried to share the document. He says, well, they must have a new capability. I said, is that possible? Because the telescopes are almost identical. Almost identical. As a matter of fact, Sofia at 45,000 feet can see things much further than HST in infrared. How is that possible? And he didn't know. So that's why I had to call you. Because I wanted to be clear that, because sometimes, when media information is put out and technical information, it might get mixed up with something else. And if I'm going to be drafting a research paper on this, using artificial intelligence based on images you guys already taken, so that the API for this machine learning program will be able to discern what you looked at before to look for any other sort of anomalies, that paper needs to be spot on, because I want to publish it. And I can't publish something that's technically inaccurate and then I get laughed at. You know what I mean? So I just thought that was strange that Hubble is not even showing in an international database at all. So I've come to the logical conclusion that Sofia has been our platform for all, optical science research.
So, just my own recollection Hubble sees out to about 2.5 microns
Hubble sees 2.5 microns. Okay, got that.
into the infrared.
To the infrared.
And,
Okay.
yeah, and then our suite of instruments. I'm going to send you a PDF on this.
Okay.
We're starting at 1 micron out to 237, which is with some other limiting factors. We're about to 250.
So Sofia can see at what's the capability of Sofia?
Out to about 250 microns.
250 microns. Now that's based on what altitude?
We can go up to 45,000 feet.
Okay, so 250 microns you can see flying at 45,000 feet in the infrared. Okay.
Yeah.
Now, can anyone pay for time with Sofia?
No, you have to propose.
Oh, so it's submit a proposal. I can put it through the university, and then based on what the proposal entails, then time gets allocated.
Yeah, and I'm going to send you the link for our observer's handbook for this next cycle too.
Okay.
So in case you want to propose.
Yeah. That's incredible.
And I'm sending you the Supernova 2014J.
Okay.
Picture,
Okay.
and you can link to that. And then, what's your email?
Yeah, send it to R as in Robert, M as in Mike, Bassano, Bassano, @gmail.
Okay.
And I'll just store that in my Google Drive.
Yeah, there's some people you should talk to. But I think you need to look at some of this stuff a little more.
What stuff?
Just some of the links I'm going to send you.
Okay, I'll do that. Yeah, but it's just strange because I was trying to get more data on HST and there's nothing. It just stopped all of a sudden, and it stopped well before 2002. It just stopped.
What where are you at Stanford?
I'm doing the graduate certificate in AI.
Okay.
And then I'm going to move on to machine learning and robotics.
Nice. Okay, well, let me get this email over to you.
Yeah, I developed an algorithm about 10 years ago that was shared with JPL, and it caught their interest because it allowed for the reconfiguration of a test and measurement device to pick up ultra low frequency, ultra high energy signal transmission. And the first thing they said was, "Who are you, and where did you get this from?" Because I guess it helped them locate something that they had trouble communicating with. And yeah, it's a multi-use algorithm that I developed. I didn't, at the time when I was working on it, it was for something else specific. And then I modified it, shared it with two professors in theoretical physics and applied mathematics at MIT. They said it was beyond them. And then 2 months later, I get an email back from one of them in a handwritten note. It says, "Robert, this may be of interest to you, and it involves black body radiation." And I'm like, whoa, I didn't even know what that was at the time. And I called them up and I said, why'd you send me Max Planck's constant in an equation? He goes, "You want to start researching this?" I say, "Well, can you help me?" He goes, "No, because what you developed in an algorithm is beyond me, but I think this may be the missing piece." So I've been researching black body radiation. And lo and behold, when I started to, tootle around with my algorithm and some other mathematics using Planck's constant, it literally opened the door for me to start doing the research on artificial intelligence with regard to image analysis, processing, and identification of specific type of bodies that are emitting a certain type of light. And if you're familiar with black body radiation, which I'm still getting familiar with it myself, I've been watching a bunch of videos on it, and let's just put it this way, it's really fascinating. I started putting together and fusing dark matter, dark fluid with super helium-4, and potentially now someone's introduced me to what sulfur hexafluoride can do. And when you combine the both, something very interesting occurs. And I think I know why we can't see things on a specific spectrum using, say, the Sofia platform or Hubble. What I'm saying is this, is there's a possibility I might have created the capability for you to see something that you're looking for that may be right in your line of view, but no one knows how to put together the calculations of mathematics. And I'm not saying you guys don't. I'm just saying that there's a possibility. And of course I can't do it from the ground, but it would require looking at the same object you might have been looking at and seeing a lot more of what may be comprising the vision of that object. You may see the other ingredients. So, but again, it's just something that I'm working on and developing, but I need clarity because obviously can't use HST. It might not even be there. It might not even be there. I don't understand why it's not in the FAI database. You know, the guy I talked to, he's been there for 25 years. He was not familiar with it at all. And when I told him about it, he says, well, we don't manage that database. But no one's ever, he said that no one on the team has ever seen HST, ever seen it. They've never seen it in real time. And my explanation to him was this. I've been in the military, you know, and when you set out an ROV or drone, you have a camera on it. You know what it's doing. You know if something comes in contact with it so you can avoid whatever. And, you know, that's, of course, for, you know, Earth-based type of remote vehicles and drones and automated systems. But if you're going to put a $1.5 billion, 43.5 foot tall telescope out beyond the exosphere, you'd like to know if something ever tried to come in contact with it. I mean, just every now and then, you'd like to flip the camera on and say, let's see what it looks like. Because you have telemetry data and signals intelligence that tells you if the thing is healthy and if it's functioning properly. But when it does go down and you can't troubleshoot it from the ground, right? You have to get a visual because maybe something might have hit the thing. And here's the interesting thing. I found out ISS can't even take a picture of HST. Now, is that not weird to you? Because they have at least, a half a dozen cameras on the ISS.
Is it because they don't come close enough? Or what?
No. Here's the thing. ISS can raise, and ISS loses and gains in altitude with every orbit, somewhere around 1 mile to 2 miles. I can show you this video online where ISS dropped from 223 miles down to 190 miles. Okay?
Wow.
They took a LiDAR photo 1,100 miles off the coast of Antarctica. It looked like it was taken from Sofia. So I thought that was strange because the person who took the photo, they did a TED conference. All right, Don Pettit. And he says that they got down, and then they jumped back up to 240 miles. Now, here's the interesting thing. I asked the deputy program manager, I said, wait a minute. HST, you said the last servicing mission was around 2008, 2009. Those missions are not even in the record books. So I didn't want to focus on that. I just said, basically, this is what I'm trying to come down to. I'm very familiar with orbital mechanics, atmospheric drag. Okay, there's less atmosphere where it's supposed to be. But if it takes an orbit every 95 minutes at 17,000 miles an hour, okay, and we're looking at least what? Let's say the last service image was 2008, you're looking at 8 years. If you go from that 8-year time span from when supposedly the STS was to push the Hubble back up into its 330 plus mile orbit, geosync orbit, from that moment, every 95 minutes, HST should be losing about 1 mile to 2 miles of altitude every single 95 minutes. How do I know this? Is because that's exactly what ISS does. And ISS is 5 to 6 times larger than HST. ISS is 100 yards long, 50 yards wide. So of course, the larger something is, the greater its mass, the more altitude it's going to lose. But ISS has propulsion systems to push it back up into low Earth orbit, correct? Guess what? Yeah. HST has no type of propulsion system to maneuver it at all. It can only change direction, meaning it can only swivel around because it's got some internal gyros that allow it to flip in a forward or backward direction or turn sideways to look at a particular area of the sky. So it has been losing altitude for the past 8 years. So if you do the mathematics, ISS is at 240, 245. Hubble is supposed to be 330, 340. So they're about 100 miles away from each other. Now, when the sunlight supposedly hits HST, ISS crew should be able to see HST and zoom in on it with a 600 millimeter, 800 millimeter telephoto lens. There's never been a single photo of HST. Now, when you look at the 8-year time frame, to this very moment right now, if you were to track Hubble and ISS based on the orbital decay, okay, Hubble should be somewhere, if I did my math, but I didn't want to exaggerate. But if you want to hear my exaggerated math, the Hubble should be 10,950 feet in the Marianas Trench. But that's exaggerating. But if you want to be more reasonable and say, okay, maybe it's not decaying 1 mile or 2 miles, even if you're conservative, Hubble should be within 10 to 20 miles line of sight of ISS. All you have to do is do the math. And when I said this to this individual, he says, I don't know where the ISS is. So I pulled up the ESA International website that tracks ISS. I told him where it was. It was on 257 miles at the time. And then I went on the website to track HST, and the data is false. The data is false because, one, it's an online API software program, and it's very easy to program in a different altitude. Whatever it is they're saying that's up there, it's not HST because mathematically it shouldn't be there. If it's decaying and it's supposedly dropping in altitude. And get this, factually, scientifically speaking, when you look at the laws of aerodynamics and astronautics, there's no way an STS could have gotten beyond ISS to service HST. They didn't have the fuel, they didn't have the capability to get up to that altitude and maintain velocity. Because you have to be
240 miles high at the time.
Well, here's the thing. If that were true, that means that HST did drop down to about 200, around the same altitude of ISS. That's the only way the STS could have gotten to HST and captured it and then pushed it back up to orbit. But even if they did push it back up to orbit, there's no way you could have created that much force and energy to catapult it another 100 miles beyond ISS. There's no way. I mean, I know the laws of physics. I understand. I learned them just as everyone else learns them. An object in motion stays in motion until something gets in its way to change its velocity, vector, and direction. But if you pushed HST up back into its orbit, that means it would have kept going. That just makes logical, scientific, basic high school physics sense. If you captured HST on its last service and had to push it back into orbit, and it has no propulsion system to stop it from going any further, that means they lost it. And that's my scientific conclusion. That when they went up there for the second servicing mission and they tried to catapult it and it had nothing to stop it from continuing on beyond its projected orbital plane and motion, that means it just kept going and they lost it.
Yeah.
It had to. I mean, Nick, I don't know what your detailed background is, but if you're the Sofia Science, you're handling Sofia Science information, you and I both know, a high school kid could put together the math and say, wait a minute, this doesn't make sense. This thing doesn't have anything to stop it. There were no jets on it or nothing. And if they pushed it back out there 6 missions, it's not there. It's just not there. And I can understand the embarrassment of someone admitting to that. I'd be embarrassed too if I lost $1.5 billion piece of technical equipment. But why not just say, oh my God, we lost it, and we're going to create the James Webb telescope. And that's why we're taking our time to make sure that we can make sure it's done right. Because that's what's supposed to replace the Hubble. Am I correct?
Yeah.
The James Webb is supposed to replace Hubble. I think that the reason why it's been taking so long for James Webb is because they need to have a vehicle they can control and keep stable. I don't understand why Hubble was designed the way it was designed. Because, when they said that an aberration was in that mirror, and I read the OIG report, and I found out about Sofia, the first thing I thought was, holy mackerel. They somehow captured Hubble, brought it back down, dismantled it, and handed it off to Sofia. Because that's what I thought. I thought that they gutted it and basically put it into a 747 and put it on steroids so it could have a 250 micron IR capability. That's my thought.
Ours was built from scratch.
No, I know. But that was my theory on it. But I don't know, HST. I don't know how you sit at a control console for 25 years and you never see what it is you're supposed to be monitoring. You just don't do that. You just don't. I mean, NASA's part of a defense agency. You don't send those type of expensive pieces of technology out into space without having eyes on, or at least having something out there that can monitor Hubble from a distance and see it. They said that there's no other vehicle asset in GeoSync that could ever come within distance of HST just to take a picture of it.
Well, we took pictures of the shuttle in mid-flight. I don't see why we couldn't.
Oh yeah, you take pictures of the shuttle in mid-flight, of course. But why not HST? And then when I saw the photos of HST being serviced,
because nobody ever asked.
well, and that's interesting. But when I saw some of the servicing missions where the shuttle is on top of HST and they're looking down at the Earth, I'm like, that's impossible. There's no way you maneuvered yourself on top of this thing. There's no way, unless it was in lower altitude. If it was in lower altitude, I provided my own answer. But, I don't know. I would look forward. Now, with this conference you're talking about, are you going to let students and maybe civilians maybe take a ride on Sofia?
No, you could go yourself and maybe, if you had a postdoc.
Okay, perfect. That'd be outstanding. Nicholas Veronico, thank you very much. Thank you very much, sir. All right. Take care, sir. You have a nice day.
You too.
Bye-bye.